Welcome to the Women in AI Research channel. I'm your host, Ekaterina, and I have recently returned from an incredible week at NeurIPS 2025 in San Diego. The conference is now over, but I am continuing to share all the most interesting insights, research highlights, and behind-the-scenes moments with you. Let's dive into today's NeurIPS highlights.
Hi, I am Sree Bhattacharya. I am a third-year PhD student at Penn State, and I work on multimodal learning and affective computing, which is to teach AI systems how to reason about emotions. And also I'm interested in other related subjective intelligence tasks like cultural reasoning and social reasoning.
Nice. I was. It's your poster caught my attention because it is named "Do Machines Think Emotionally?" So do they?
It depends. Mostly not is what we find,
Okay.
and especially like they think emotionally to some extent, but they're not very aligned with how humans think emotionally, and they're also not very consistent in how they think about emotions, how they reason about emotions.
I see. Interesting. So can you maybe walk me through quickly?
Yeah, sure. So the question that we ask is basically what you already asked, that are LLMs capable of reasoning about emotions, and are they capable of doing cognitive reasoning about emotions specifically? So to answer this question, we use this theory called the theory of cognitive appraisals from psychology and cognitive science, which basically says that different people feel different emotions in certain situations because of how we appraise or interpret the situation. So the two same people in a given situation could feel very different because of how differently they appraise the situation. And this theory basically provides a framework for people to reason about why they feel emotions in a certain situation. So just to give a very simple example, if I ate my favorite food and I felt really happy, then there could be reasons as to why I feel happy, right? Maybe because it was very pleasant, very enjoyable, and it was very low effort. I did not have to work hard to like get my favorite food. So maybe those are the things that make me happy. So this theory provides like these many different dimensions, like I said, say effort, pleasantness, or responsibility, like who is responsible for the situation. And using this and like this seminal human study in psychology, we create a benchmark to evaluate LLMs where we have these different dimensions, we have these different emotions, and we create prompts like these where we ask the model that imagine you were in a situation where you felt happy or any of the other emotions. There are many other emotions that are not shown here, and then we ask it like how pleasant do you think the situation was, or how high effort do you think the situation was, and it provides ratings out on some scale. And then using these ratings, we conduct a bunch of analysis. The first thing that we look at is how or which dimensions out of these are the most important or the most dominant for models. And we also compare that with humans. So for humans, what the previous like study found is that pleasantness or perceived fairness, like how fair is the situation, are really important dimensions. Whereas for LLMs, most LLMs, effort, like how effortful is a situation, is something that they consider most important. Like this explains most of the variance in their data. And along with this, like this is definitely a key part of misalignment with humans, but along with this, we also experiment by asking LLMs explicitly. Like we provide them with the situation and we say that you felt happy in this situation, and what dimension is going to be important for you, like what values can they explicitly state. And there we find that they report a completely different set of dimensions. So they think that they would use perceived fairness in making emotional judgments, but they actually use something else, like they use effort. So not only are they misaligned with humans, they're also like inconsistent amongst themselves, like within the same model. The next thing that we look at is how well are LLMs able to make connections between these dimensions and the emotion. So in terms of theory from psychology or like other human studies, can LLMs make plausible correlations between these dimensions and emotions? And we see that they mostly can. So that's one part where they are good at, or relatively good at, or most of them are good at. For example, if you look at this, say like for challenge, you see that self-control is very highly positively correlated, whereas certainty is negatively correlated, which intuitively and from theory it makes sense, because if you're in a challenging situation, you know that you can do it, but you're not very certain about it. So it's like in your control, but you're not very certain. So that's one thing that we find. And then finally, we look at how LLMs represent emotions in their internal sort of knowledge space. And to do that, we use these ratings as an interpretability mechanism. For example, if you look at this, these are basically just distances of the different emotions within each model. So how are these emotions clustered in the knowledge space of the LLMs? And if you look across these three graphs, out of the 7 models we show these 3, you'll see that there's this like small box here, and then there's this large box here, and it's kind of similar for all of the models, which shows that these are really close and clustered together, and these are close and clustered together, and there's some like separation between the two. But it also basically shows that these models, they are only able to separate emotions based on valence. Like these are all positive emotions and these are like negative emotions. So higher order cognitive dimensions like attention or certainty, these are not something that the models can think about and reason about very well. And then the last thing that we look at is that in humans, there are around 6 emotions that are considered universal, like happiness, sadness, disgust. Like most people think of them or appraise them very similarly. And we see if that's true for LLMs as well. So for each emotion, we collect the entire appraisal distribution and we compare across models about whether they're similar or not. And what we find is that they're different from each other, and that the difference is also like statistically significant. So in LLMs across different models, there's not really a concept of universal representation of emotions. And the implications of all of these are, I would say, many, but the most important thing would be that for subjective tasks like emotions, you would see many models doing well on simpler predictive tasks. Like maybe you give it an image or a tweet and you ask it to like predict, and it's able to predict, but then the underlying reasoning is not robust or it's not aligned with humans. So that's like the main thing to look at.
That's a super interesting work. I wonder, when you think about that universal emotions across models, have you tried to use just different models or different sizes of the same?
That's a great
model
question.
family?
That's a great question. So I did not try with, like, I would not say that I ran experiments across like within the same model family or for all of them, but for some of them, like as a pilot experiment I did. And it seems like within the same model family, they're very similar to each other.
Okay.
But across different model families, there is this difference.
I see.
Yeah, and I would like to dig deeper into why it's there. Yeah.
What about the emotions in humans? Are they universal? Are they considered to be universal for humans or across the whole animal?
I think it's just for humans, like
right.
because
so in that case, probably different models are like different species.
they're not. Yeah, that's true. That's true. That's also a good way to think about it. Yeah, but I think part of the like the concept of having universal emotions also comes from like facial expressions for humans, which is definitely not applicable to like LLMs. So yeah.
I see. What do you think is what can we? How to make sense of this type of work? Like why it is important to understand, to figure out how LLMs understand emotions, if it is consistent, if it aligns with humans.
That's again a great question, I would say. So I think there are many aspects to it, but the primary thing is that LLMs are going to get used. They are getting used in, say, high stakes decision making scenarios, or even say as like mental health partners. Like many people turn to LLMs for like advice on these, and we ultimately want them to provide responses or make decisions that are aligned with our like values or beliefs or what we want. And for that, you want to know that how they think also must not be in a very bizarre or very different way. It should be aligned to how humans think. I would say that's like one aspect of it. And then there's also the aspect of whether LLMs can be used to sort of simulate humans. Like, can you use them to simulate, say, large societies? Can you use them to simulate humans in social science research? So one of the biggest bottlenecks is when you want to collect human data from a large population, it's hard to do that because you cannot like collect from all of the world. But then can you use models to simulate that? I would say these two. And then ultimately, I think the third thing is just like scientific curiosity. You would want to create intelligent systems that mimic humans very closely.